For those of you who don't know who I am, my name is David Hudson. I'm a third-generation Phoenix cotton farmer. I got involved in this quest about 1975 in doing analytical work on natural products on our farm. I became very intrigued with the chemistries I was seeing because, in fact, the chemistry was not, in fact, what the analytical data was saying it was. In other words, I would send the material to a lab to have them tell me what was there, and they would tell me one thing, and then when I performed the chemistries on it and actually saw the chemistries, it was something totally different. And so, my interest in whatever this material was quite profound. You have to understand, I am not a chemist. I have never studied physics. I've never studied chemistry. I'm just the guy that paid for everything. I do find that present I am teaching some of the top physicists in the country. I'm working with Westinghouse and GE and people like this. They bring in their top physicists, and when you finally get up to a level of understanding, like when I spoke down in Santa Barbara, I was explaining superconductivity to them, and the man was sitting in the front row just kept nodding his head, nodding his head. And after I finished, the gentleman came up and he says, "Dave, I worked with Bardeen of Bardeen, Cooper, and Schreiber at his laboratories, and this is the Nobel laureate for the theory of superconductivity." He said, "Your explanation of superconductivity is very, very accurate, very correct, and I find it just profound that some farmer would understand it." So, when you do get up to the level of understanding where you are talking to people who do know their business, then they appreciate this. Otherwise, they don't. So, if you do understand this, you are up in the top 1%. You're very, very elevated, which says a lot for your teacher. I want you to know that in all of my work in science, that I have never encountered anyone who understood it as clearly and precisely as the tapes that I listened to this afternoon of Romson making a presentation. I can only tell you that it's very embarrassing to hear my name mentioned in the presentation, and then the jokes are being made about me. I think it's important for the people who don't know how I am that if the ones who've already heard this will bear with me a little bit while I go through a little bit of the background. As I began to investigate this unknown material, basically the area that drew me very strongly into it was our work with soils. And we were actually have a problem in Arizona called a sodium problem, and we have the high sodic soils, which means the soils have a lot of sodium in it. And so we were actually buying sulfuric acid from the mines and bringing it in tanker trucks and injecting it on our soils in 6-inch ribbons in the soil at 30 tons to the acre. Now this was 93% sulfuric acid, 30 tons to the acre. In doing this, what would happen if we use irrigated agriculture, we don't get rainfall like you people here. We get about as much rainfall in a year as you get in 2 or 3 days here. And so we were actually putting it on our soils and putting the irrigation water on behind the tractors. And as this water ran across the field, it would hit this acid, and the acid would just froth and foam and bubble and suds. But what we were doing is we were making sodium sulfate, which is called the white alkali, out of sodium, which is the black alkali. And the white alkali was leachable. The water would dissolve the white alkali and wash it out of our soil. And so we're able to leach the white alkali out of the topsoil. In doing that leaching, one of the things we had to be very careful about is you have to be sure that there's enough buffer substance, something that keeps the pH stable in the soil. And so we had to find out whether there was a lot of calcium carbonate in our soil. Because if there wasn't a lot of calcium carbonate, what would happen is you put the sulfuric acid on, it would really drop the pH, and then you couldn't produce anything. You could germinate seeds, but the plant would get about this big and just quit growing. It just had none of the trace nutrients that are associated with the crops we were raising in Arizona. And so in the investigation of what I had in my soil, I kept running up against this stuff, whatever this stuff was. So finally I just committed, I'm going to do an investigation of this material. I'm going to find out what this stuff is. Now, keep in mind, I know nothing about chemistry, nothing at all. I just take it to commercial laboratories, they run the work. So we actually got this material, dissolved it out of the ore, and basically our ore, our soil is a decomposed rock. It's just dirt. There's no topsoil. There's no organic material. It's just dirt. So we took the dirt, we dissolved it in acid, and we got it in solution. Then we added powdered zinc to the acid, and it precipitated out as a black. And we filtered the black out on a filter paper and got it totally dried, and we set it out in the sunlight to dry. And as it dried in the sunlight, it exploded. Now, this didn't make any sense. How could you have an explosion of a metal? It didn't make any sense at all. And so we did it again. We got it all in solution. We added powdered zinc. It came out as kind of this bluish-black precipitate. We filtered it out, put it out in the sun, and as we dried it, it exploded. But we got to looking, and what had happened is our Pyrex, or our porcelain filtering funnel, was fractured and cracked from the heat. And I said, well, you know, this is really interesting because it doesn't seem like there's any explosion or an implosion. It's just tremendous release of short-wavelength light. And I said, you know, whatever's going on, this is not like any explosion or explosion I've ever seen. So what we did is we actually took a brand new pencil that had not been sharpened, and we stood the pencil on its end next to the filter. We put the filter out to dry, and as it dried, it exploded. But when it did, it burnt the pencil about 1/3 in two, but it didn't knock the pencil over. Now this just is not explainable. It's not explainable with any understanding of chemistry that we had. It was like there was a tremendous release of energy from this material, whatever it was, whatever the stuff was. Tremendous release of light, but it was like 50,000 flash bulbs all being ignited all at the same time. Just a tremendous burst of heat, but no gas. And this just didn't make any sense at all. I was perplexed. The people working with me were perplexed. I said, this just doesn't make any sense at all. I sent it to commercial laboratories. I say, what's in this stuff? Now, do understand, I took it out of the sunlight and I dried it inside, and it doesn't explode. So I dried it inside, sent it to commercial laboratories for analysis, and they told me I had iron, silicon, aluminum. Now this is just the mundane, lowly, ordinary elements of the earth. Just about any dirt you pick up has iron, silicon, aluminum in it. And I said, but iron, silicon, aluminum don't explode. And you can't tell me a compound you can make them into that explodes. And they said, well, that's right. And I said, then when it's totally dried, it will not redissolve in any acid. They said, gee, is that right? And I said, yeah. And they said, well, it's iron, silicon, aluminum. So, anyway, I did go back to finally to Cornell University, where there was an expert that took me months and months to locate, but a man who claimed to be an expert on metals analysis. And when I got it back at Cornell University, he put it on this tremendous, and I say tremendous, it was a huge, huge instrument. From behind glass doors, here was these 8 different microscopy heads that actually did X-ray diffraction, X-ray fluorescence, tunneling microscopy. All these different types of analysis were all set up on the one sample. And he says, Dave, we can analyze down to 3 to 5 parts per billion on any material above chlorine on the periodic table. I said, well, gee, this will solve it once and for all. We'll find out really what I got here. So he put it on there, turned the machine on. He says, Dave, you've got iron, silicon, aluminum. I said, no, sir, I do not have iron, silicon, aluminum. You cannot come up with a compound of iron, silicon, aluminum that's a blue-black in color. And he looked it up in the CRC, and he said, well, there's ferrocyanide, and there's, you know. I said, but that doesn't have the chemical properties this has. So finally I got so frustrated, I said, well, do you have a chemistry lab around here we can go to work? I want to show you how this stuff reacts in acid. So we took it over to a chemistry lab, and we played with this for like 4 or 5 hours.